Before a hacker even thinks about hacking a website, they ask it one question, over and over. What are you hiding? And one by one, the site tells them everything. That's exactly what we're doing today, pulling out everything our target hides, but never actually secured. Everything here runs against VulnMart, a target I own, because running these tools on any system without written permission is illegal. So keep all of this inside your own lab. By the end of this, we'll have the full hidden map of the application. Secret directories, forgotten files, and the back-end routes buried inside the site's own code, all before we attack a single one of them. Stay with me. First thing we always do is update the system. Run sudo apt update to refresh our package lists, then sudo apt upgrade-y to install anything pending. Mine's already up to date, so this finishes right away. Now let me set up where we are. Last time we ran Nikto, and it found problems by checking the target against a database of things it already knew to look for. Outdated software, known misconfigurations, a couple of exposed files. That's scanning. Today is enumeration, and it works in a completely different way. Here's the difference that matters. Nikto knows what to look for. Enumeration knows nothing in advance, so it tries everything. The tool we use, GoBuster, takes a word list of thousands of common directory and file names and throws every single one at the target to see what answers back. Nikto found the admin page because admin was in its database. GoBuster would find a custom panel called internal management, or a backup called database export, or a test page called test payments, because it doesn't need to have seen the name before. It just tries them all. Then we go one step further with JavaScript analysis. Every modern site loads code into your browser to make the front end work, and developers hide things in that code all the time. Back-end routes, API endpoints, sometimes even credentials, sitting right there in a file every visitor downloads. No scanner checks for it. But a pen tester who reads that file finds things that would take weeks to uncover any other way. Together, these two techniques hand us the complete picture before we attack anything. GoBuster comes pre-installed on Kali Linux. Confirm it's ready with GoBuster -- version. Version 3.8.2, nothing to set up. But GoBuster is useless without ammunition, and that ammunition is word lists. Install the collection with sudo apt install -y SecLists. SecLists is a massive set of real directory names, file names, usernames, and passwords pulled from actual web applications. This is what GoBuster fires at the target. Now let's bring up our lab. Move into the folder with cd VulnMart. Make sure Docker is running with sudo systemctl start docker. Then start the target with sudo docker -compose up-d. Both containers come up healthy, and VulnMart is live at localhost on port 8080. Take a quick look at what GoBuster offers with GoBuster --help. It has several modes, but today we use dir mode for directory and file discovery. Let's look at the word lists we have. List the web content folder from SecLists with ls, pointed at the discovery web content directory. Dozens of lists for different jobs. Quick ones, deep ones, API lists, extension lists. We start with common.txt. How big is it? Check with wc-l on common.txt. 4,749 entries. GoBuster is about to try every one of them against VulnMart in seconds. Now the main event. Write GoBuster dir with u pointed at our target, w pointed at common.txt. Run it, and watch what comes back. There's .ht password, returning 403. That's a password file. It exists, but access is blocked. On a misconfigured server this would be readable, and it would hand over credentials directly. Then, .ht access, also 403. That file controls web server behavior. It exists, but the server is blocking access to it. Good. Then, .hta, blocked as well at 403. Another server control file the server refuses to hand over. Now admin, returning 301, redirecting into the admin folder. The admin panel exists, And it's reachable, found in seconds with nothing required to see it. Then, API 301. An API directory. We dig into this in the JavaScript section coming up. Then Assets 301. This holds the JavaScript files we analyze in a moment. Then includes 301. Internal PHP files that should never be publicly reachable. Then index.php, returning 302, redirecting straight to login. The site's front door, sending anyone without a session to the login page. Then server status 403. Apache's live status page. Blocked here, but on a misconfigured server it exposes real-time connection data. And uploads 301. The file storage directory. We come back to this one in the file upload video. 4,750 entries checked, 10 findings, done in seconds. Nikto found admin and config in its database. GoBuster went further and found the API directory, the assets directory, the uploads directory, and the includes directory. 4 fresh attack surfaces Nikto never reported. Now let's add file extensions. Run the same command again, but add -x with the extensions we want: PHP, text, backup, and zip, and -o for the report file. Now GoBuster tries every word list entry combined with every extension, and this is where the real findings show up. There's config.php at 200. Nikto flagged this, and GoBuster confirms it. Status 200 means it exists and responds with nothing required to reach it. Login.php at 200. The admin login page, publicly reachable, no protection. Register.php at 200. Registration is open, so any visitor can create an account. Version.php at 200. A version disclosure file, sitting open, handing out the application version so an attacker can look up matching exploits. And notice all the other PHP pages: cart, checkout, profile, search, orders. They redirect to login with a 302. They exist, but need a session. Those become our targets in the manual testing videos ahead. One more. Notice.htaccess.back at 403. A backup of the server security config. The file exists, and in a different setup it would be readable, exposing every security rule the server enforces. The report saved itself while the scan ran, right here in the lab folder. Open it with cat and the report file name. Every finding, every status code, every redirect. This joins our Nikto report from last time, and together they're the complete checklist we work through in the videos ahead. Now the second technique, JavaScript analysis. GoBuster found the assets directory, and inside it there's a file called app.js. Let's read it with curl pointed at that file. Look at this object near the top. It lists the application's API endpoints in plain text: search, products, user, orders, admin, checkout, coupon. 7 backend routes. GoBuster never found most of these, because they aren't exposed as directories on the server. They live only inside this file, running in the browser. The developer wrote them here to make the front end work, and now anyone who reads this file knows every backend route the app uses. Look at the admin one specifically, an admin API endpoint, named right here. We test that directly in the API testing video. Now scroll down to this debug block. Debug is set to false. The developer thinks that switches off the code below it. It doesn't. The code is still here, the token is still here, and anyone who opens this file can read it. And there it is. A hard-coded internal API key, right there on screen, and the admin endpoint it unlocks. Left in the live code because the developer assumed setting debug to false made it invisible. It didn't. Let's confirm all this the way an attacker would, in the browser. Open Firefox, log in as admin, and press F12 to open Developer Tools. Click the Network tab, filter to JS, and hard reload with Ctrl-Shift-R. There's app.js in the requests. The browser downloaded it automatically the moment the page loaded. Click it to preview the source. This is what your browser pulled down without you ever asking, and every visitor to VulnMart gets this same file. Now click the Debugger tab and open app.js in the Sources panel. Search inside it with Ctrl F, type API, and every API reference lights up. Type token, and the hard-coded credential jumps out. Type admin, and the admin endpoint highlights. Type key, and the API key appears. 4 searches, 4 categories of sensitive information sitting in code any visitor can read. Now let's use what we found. Browse straight to the admin panel at the admin path. There it is, fully loaded, every user account listed. Right now we're logged in as admin, so this is expected. The real question is, what happens when someone reaches this page without admin rights? And that's exactly what we test in the broken access control video. Then browse to the uploads directory. This one returns forbidden. GoBuster saw it at 3:01, but browsing it directly is blocked, so we can't list its contents. The directory still exists though. And in the file upload video, once we plant a file in here, we reach it directly by its full path, even though the listing is blocked. That's enumeration. 2 techniques, 1 goal, map everything the target has before we touch it. GoBuster charted every directory and file, and the JavaScript gave up the API routes and credentials hidden inside the app's own code. And every one of those findings existed for the same reason. The server was handing out information it never needed to share. The next video is where everything shifts. We stop collecting information and start intercepting live traffic, using the one tool every professional web pentester runs for every manual test in this series. If you want to follow along, make sure your setup is ready before then. Drop a comment and tell me which finding surprised you more, the admin panel GoBuster walked us into, or the token sitting inside the JavaScript. I read everyone. Until then, this is Tech Sky, your ultimate battleground of cybersecurity and ethical hacking. Stay curious, stay ethical, and keep learning.